All right, hello everyone. Welcome, welcome. Hope you all had a great weekend this past weekend. Let's start off the day with just a couple of announcements. I'm sure you're all curious as to how the exam grading's been going, or maybe not if you read my announcement earlier on today. But the answer is pretty good. We've actually are finished with most of the exam grading. Like all exams, however, there are a few little odds and ends that we have to clean up before we can release the grades, and that's the phase that we're in right now. I don't think it's going to take us much more than another day or two to kind of get all of it wrapped up and get the grades posted. So, maybe tomorrow, but definitely by Wednesday you'll have your exam 1 grade in hand. So far the scores have been looking pretty good as well, so that's good news. The other thing that I kind of wanted to make sure everybody was aware of, we have no class next Monday because of fall break. So yes, we do have our normal class this week. We have class today, of course, and we have studio on Wednesday, but next Monday nobody will be here. I'm not going to be here, Professor Nuri's not going to be here. We're going to be enjoying our day off, and I hope you all do as well. We do still have studio next week on Wednesday. There's nothing special that you have to do to prepare for it. We're not introducing a new topic or anything. It's kind of a little side quest, I guess, a little side studio for us to work on in the lab on Wednesday. But it's going to be a pretty chill couple of weeks. That's kind of the nice thing is that we just had our exam last week, but this week is going to be pretty chill. Next week's definitely going to be pretty chill with the fall break at the beginning half of the week, so things are going to kind of slow down a little bit, at least until we get to our next exam, which is at the end of October. So that's kind of what we're going to be working our way towards for the next few weeks. Does anybody have any questions about logistics or the schedule before I start hopping in and taking a look at some code for today? Any questions about what's coming up over the next couple weeks or so? Awesome. All right, well, we're going to have some fun today then. This is actually one of my favorite topics to teach in the whole semester, and this is one of my favorite little demonstrations to do out of all the ones that I give in this class. So I would highly encourage you all, if you have your computer with you, to try and follow along coding with me today. Just so you're all aware, right, we finished our first exam, so the class is kind of broken up into thirds. So we finished the first third. This is the very first day of the second third of the class, the second chunk of the class, which means that you're going to have to download another repository of exercises. So the Module 4 exercises aren't going to be in that batch that you downloaded on the first day of class. We have a new batch for the next few weeks leading up to the second exam. So if you haven't done that already, please make sure you grab the repository for modules 4, 5, and 6, which are the topics that are going to be on our second midterm exam coming up at the end of October. And actually for today, while there are several examples here, I'm going to be focusing mostly on this one that I've got highlighted right here that involves a moving ball going across the screen. I really hope you had a chance to look at some of this stuff before coming to class today. I know that we don't expect you to be experts or know everything when you come in, but I really hope that you had at least a little bit of a chance to look at this, because I'm going to be trying to tie in as much stuff from the prep work as I can while I build a little game for you all from scratch here, mostly from scratch. I am going to get a little bit of a head start, but we're going to be coding up a little bit of a game here today. And in order to do that, we're going to use something called standard draw, which is an example of an API. So API is the main topic of this week, right? I know it might seem like drawing stuff on the screen is the main topic of this week, but really, we're trying to get you to think of this concept of an API, which is short for Application Programming Interface, which I know probably still doesn't help clarify things too much if you haven't done a lot of coding before. So let's talk about it maybe in more human terms, right? What is an API? What do programmers use APIs for? APIs explain how to use a certain piece of code. So the piece of code that we're going to be looking at today for most of the day is called standard draw, and that code helps us draw things on the screen. So if you think about it, drawing something on the screen is actually a fairly complicated thing to have to do. You're probably aware that your screen is made up of tiny little things called pixels, right? So if I want to draw a circle, for example, I have to decide exactly which pixels on the screen I want to turn on and have be a certain color. There's actually a lot to it. But fortunately, we don't have to worry about any of that because Standard Draw provides the ability for us to say, in more simple terms, draw a circle at this point. And then it takes care of all of the complicated stuff for us. It takes care of all of the pixel manipulation stuff for us so that we don't have to worry about that. And we can think about the higher level stuff. We actually, as humans, do this all the time. An example you'll hear me bring up often that relates to this is driving a car, right? I'll be the first to tell you that I have no idea how engines work. I know a little bit, but I'm certainly not a mechanic. I certainly could not fix an engine if I had to fix an engine. Maybe if you gave me like a whole bunch of time and a lot of information, I could get there eventually, but I don't have that knowledge in my head. I know how to drive a car, as I'm sure many of you do, right? So I know that the inputs to a car are a steering wheel and a gas pedal and a brake pedal and all the knobs and buttons that come on the dashboard, right? So I can control the car without having to know exactly how the car goes vroom vroom. You get what I'm saying? Like, there are certain things that I can just take as, yes, it's gonna work. I push the gas pedal, car goes vroom vroom. I push the brake pedal, the car stops. I don't need to know how all of those things happen in order to know that that's how a car works. It's the same concept that we're using here today. I can tell the computer to draw a circle on the screen and not have to worry about all of the little details necessary to make that happen. I can just focus on what I care about, which is the coordinates of the circle, what color the circle is, things like that, things that I want to control. So Standard Draw is the API that we're going to be using to do that. And if you haven't already, I link to the Standard Draw API in almost every single page of the prep work, but also too, if you just Google Standard Draw, you'll very quickly come across the link from Princeton University, who is responsible for creating this drawing code for us. And this is something that I'm going to be referring to a whole lot today. This is the API. This is the list of stuff that I can do with Standard Draw. So you'll notice that a lot of it's related to drawing, but there's actually other stuff involved in here as well that I'm interested in talking about, such as text, such as images. We're not going to talk about images today, but that's actually a really fun one that students like to experiment with. Animations, definitely we're going to be talking about, but also keyboard and mouse are things that I'm interested in as well. So there's really a lot of stuff that can happen. There's really a lot of stuff that this code can do for us, but all we need to understand in order to use this code is just how to read this API and incorporate it into our own programs. So a big part of programming is accepting the fact that I don't know everything. There is no possible way to know everything, but if I want to do something, I can look it up. That is one of the things that I really try to emphasize in all of my classes, all of my programming classes, is good programmers don't know everything, but they do have the confidence and the ability to go look stuff up when they want to do something that they don't know how to do. And APIs are like your #1 resource for reference, for filling in the gaps. We've actually already used an API in this class before. Can anybody think of an example of an API that we've already used in the last few weeks? Yeah. Math, yeah, math is a great one. We're going to be using math a little bit later on. So, the powers and the square roots and all that stuff, I don't have to tell the computer how to do that stuff. There's a math library, and it says if you plug in the base and the exponent, then you'll get the power back out, right? You'll get the computation back out. And there's another one we've used as well. Can anybody think of a different one we've used? Yeah. Scanner, yeah, scanner's another great one. So scanner says, once you have this scanner thing, you can ask for another int, you can ask for another string, you can ask for whatever you want the user to type in on the keyboard, right? Those are examples of APIs. In fact, I'd like to take a moment, slight detour, and say, all right, what if I wanted to know what scanner can do? Well, we can type in scanner Java, for example, and if I'm looking for APIs on Google, if I'm searching for help, what I'm going to look for Java especially, is the page that is listed as being from Oracle. Oracle owns Java. Oracle is the company that makes Java, that owns Java. So this is the quote-unquote official documentation. This is the official Java Scanner API. And if you click on it, this is what the page will look like. You'll notice it looks kind of similar to the standard Java API. The colors might be a little different, but in general, this is what Java APIs look like. They have this kind of style, they have this kind of format, and at the very beginning, you'll notice that it gives us some simple instructions on how to get the scanner up and running that looks very similar to how we've used it in our examples, right? And shows us some other tips on how we can use the scanner. And if we scroll down a little bit farther, we'll see that eventually we come to this list, which we'll talk about when we get to module 7 in a few weeks. But the list I'm more concerned about right now is this one called method summary. These are all the things that the scanner can do for us. And if I scroll down eventually, we'll see that we get to the ones that we recognize, such as next, or next double, or next int. Those are the ones that we've used before, right? Those are the ones that you've been asked to use before in class. There's a whole bunch of other ones that you haven't been asked to use before. But if you needed to do something, right, the ability is here for you to refer to this documentation and see exactly what it is, you know, that the scanner is doing for us. And if you click on one of these, it even takes you down to a more complete description. Although, I think a lot of you would probably read this and say, what is that even saying? You know, there's still a lot to learn, right? So don't ever feel like you're gonna automatically understand anything. Keep Googling, keep looking stuff up, keep learning. That's the way you get better at programming, is recognize, oh, well, this I don't know what this means, but let me do some more research, let me do some more reading, see if I can figure it out. Of course, we already know what nextInt does. We've used it before, and that's maybe the best way to try and learn how to use an API or try and do something new, is to just write a little piece of code and try it, see what the code does. So the API shows us what's available, and it's then up to us to decide how to incorporate this into our program, learn how to use it properly. So to get back to the task at hand for today, I want to start with this example that involves a moving ball. And I'm going to go ahead and run this example for you real quick to show you what it does. And then we're going to start modifying it. We're going to start tweaking it a little bit. There goes a moving ball, just as promised, and you'll see that once it gets all the way to the right-hand side of the screen, it magically warps back to the left-hand side of the screen and starts the process over again. This is an animation. There's motion involved, right? This is an animation. And one of the big things that we want you to take away from this topic this week is how do we make animations on the computer? It requires some knowledge of animations in general, so I'm going to take another little side detour and talk about that for just a moment. We get animations by drawing many still pictures, right? So an animation is many pictures drawn one after the other very, very, very fast. We call those individual pictures frames. So any of you who are involved with film or video games are probably already aware of this concept, right? The general standard is, you know, we probably want 30 frames per second at a minimum, and more is better. More will give you a smoother, you know, less blocky looking animation. But that means that within 1 second, we're going to draw 30 different pictures, right? And each picture, that ball is just moving a little bit farther and farther across the screen. That's how the animation works. Well, let's talk about it in code. Let's go through this code example and sort of break it down and talk about how the animation happens. If we look at the first part of the code right here, we're just setting up some stuff. Specifically, here is the x coordinate of the ball, a variable for that. We're setting what we want the color of the ball to be, and this is going to be the radius of the ball that's driving across the screen. And then here is where we actually get to the first part of the animation. There's 3 parts of any program that does animation for us. And this is the first one. This might seem like a silly loop to write. How long is this loop going to go for? Forever. It's an infinite loop. When we talked about loops a few weeks ago, we kind of talked about how infinite loops are generally not desirable, usually kind of a bad thing that we want to avoid. But this is a situation in which actually an infinite loop is okay. It's just going to keep running as long as we want it to. Keep in mind that we have a way of exiting this loop by clicking the X on the window, which is not really something that we had access to on the programs we were doing before today that didn't use graphics, right? So really, this is what exits the loop for us. But this is the first part of our animation, and I'll label it as such. We need an animation loop. So each time through this loop, we're going to draw one frame. Every single time through this loop, we're going to draw one frame. How do we draw a frame? Well, actually, the first step is to clear the canvas. You'll see that's already labeled for us. We've got to get the old frame off. So I have to take the old frame off. So that's step one. We're always going to clear the canvas. We're always going to remove the prior frame. Step two then is not just to update the position of the ball, but consider for more complex animations, it might be more than one thing that's moving, right? In fact, later on today, by the end of this class, we're going to have more than one thing moving on the screen. But for now, we just have one thing moving. I would say more generally, we're going to update the positions of all moving objects here, right? Right now we just have one. But if we had more than one, we would want to update the position of all of the moving objects that we have. And then finally, the last step would be this section down here, where we draw everything on the canvas, and then we have to wait a little bit. So these two lines here is going to display the frame, and then this one is really more important than it might seem. It's saying we're gonna wait a little bit. And this number that's given inside the parentheses tells us how long we're waiting in milliseconds. So that means that we're pausing for 10 milliseconds per frame. And you know, you can do some math in your head, right? For this, we're actually cranking the frame rate up pretty high. There's 1,000 milliseconds in a second. So if I'm pausing 10 milliseconds for each frame, that means I'm doing roughly 100 frames per second. That's a lot. That is a lot. You can definitely get away with less than that. In fact, it's interesting to kind of experiment with this number and see what effect it has. Here it is at the original 10. But what if I close it and make it 20? That means that the frames are going to stay on screen longer, which means that the ball should be moving faster or slower? Slower, right? Slower, because the frames will be on screen longer. And you can see that, yeah, in fact, it does move a bit slower. So this is already one number that has a pretty significant effect on how our animations work. And there's definitely some trial and error here once you get something working to figure out what the frame rate is. There's a lot of stuff that goes into it, how powerful your computer is. Those of you who are gamers know this, right? You can't crank out 60 frames per second if you don't have a computer strong enough to do it. Now that's not a problem for this. This isn't a video game, right? But it could be a problem depending on how much stuff you're trying to do in your code. You could slow your computer down if you don't have enough horsepower for it. But let's get back to kind of tweaking this a little bit. I want to make this perhaps a little bit more interesting and change the motion of the ball. Perhaps instead of this magical warping, that feels unnatural, right? For the ball to just magically warp back to the left-hand side. I want to make it feel a little bit more natural. Maybe I could have it bounce off the wall instead. I think that would be something interesting to try and do. So let's think about what we would need to make that happen. We're almost kind of diving into physics territory a little bit here. So actually, for starters, before we get into that, let's talk a little bit about the coordinate system, because that matters a lot, especially when we're talking about motion and things like that. Does anybody remember, there is a coordinate system here, right, for this screen. Does anybody remember from the prep work where I'm going to find the 0, 0 on this screen? Where is my origin point? I see somebody pointing. Where are you pointing at? The middle? It's at the bottom left corner. That's correct. It's at the bottom left corner. So the bottom left corner is 0, 0. The top right corner then is, it's 1, 1. It's 1, 1. So as we're moving the ball around, as we're talking about the position of the ball, if it's right smack in the middle, it's actually 0.5, 0.5, correct? So that's an important thing to understand. And actually, although I'm not going to do this today, I would encourage you to maybe think about, you can go into and use stuff from the Standard Draw API to change that coordinate system if you want to. You can make it go from 0 to 10, for example, instead of 0 to 1, if that better suits your program. You have the ability to do that. But okay, let's go back to the task of making this ball bounce. We have a variable for the ball's position, but if I'm talking about making it bounce and move back the other direction, I think I might need another variable. What do I need a variable for if I'm going to start tracking how the ball is moving? Yeah. Direction, or if this was physics class, we would call it velocity. Yeah, velocity or speed I would have accepted as an answer as well, right? The ball has a velocity. The ball has a velocity. So let's make a variable for that, right? Ball velocity. And we want to be careful about how we set this. It probably needs to be, you know, some positive value. If it's 0, it's not going to move. If the velocity is 0, right? So it has to be some positive value. It actually already has a velocity. We can see that this number right here is the ball's velocity. Do you see that? It's a little tricky to determine though. This is an example of something that we call a magic number. Magic numbers are kind of bad in computing. An example of a magic number is a number that is just tossed into a line of code like this with no context, right? I could determine that this was the speed of the ball or the velocity of the ball, but I had to think about it. I had to look at the line of code and reason about it. Couldn't I have just labeled this number instead? And we label numbers by making variables. So don't just hard code numbers into your code and expect other people to know, oh yeah, that's the velocity. Call it the velocity. Make a variable called the velocity and put that number in there for the velocity. So instead of having it hard coded in that line of code, I'm going to make this variable for the velocity of the ball, and I will use that variable like so. Everybody with me? Everybody see what I just did there? We haven't actually fixed the bouncing yet or anything like that, but we're getting there. We know that the ball needs to bounce when it hits the right edge of the screen, and we already have a check for that. Do you see? It says if the x position of the ball is greater than 1, where 1 is the very far right-hand side of the window. So if it goes past that right-hand side, we can see that inside of this statement we set the x position of the ball to 0. But that's not what I want to do anymore. Now I want to make the ball bounce. And I'm not worried about friction or, you know, any of that stuff. We'll do pure elastic bounce. So if I was going to the right, I now want to move to the left. What does that mean for my velocity? How do I pull that off? You just flip the sign, right? You just flip the sign. If I was going to the right, I now want to go to the left. So instead of saying ball x is equal to 0, I'm going to say ball velocity is equal to negative ball velocity. I'm going to flip the sign. So I haven't made that many changes to the code yet. All I did was introduce this variable for the velocity, and I tweaked a couple of lines down here involving the velocity. Let's see what effect that has after I run this update. Oh, maybe I should have increased the frame rate because it's still moving a little bit slowly, but here we go. Ah, yes, we got it. We got there. It bounced. It's going all the way back, and uh-oh. Okay. Well, now it's gone through the wall and, you know, it's on its way past whatever Tisch Park's out there on the other side, I guess, and it's going through the engineering school. But I could fix that problem too, right? I can make it bounce off the left wall instead. In fact, I kind of already have what I need to do it. How do I make it bounce off of the left wall? What do I need to do? Any ideas? What code I would need to change? Yeah. Yes, I love it. So this is checking the x position of the ball to see if it's moving too far to the right. I mean, the same thing would work too far to the left. Another answer that I would have accepted is, let's copy this if statement and make another one for the left wall. But we actually don't need that. And I love the answer that you gave that said we can actually just do a conditional, right? If the ball is off the right-hand side, we want to flip the velocity. But if it's off the left-hand side, we also want to flip the velocity, right? So we can say that if the ball x is less than 0. Everybody understand? I hope. And so now if we try this again, I'm gonna make the frames a little faster so we don't have to wait as long. So we don't have to watch it as long. And now if we do this again, hopefully we'll see that we get bouncing off of both sides and not just the right-hand side. There we go, perfect. And now we're constrained, except for, you may guess where I'm gonna go next, right? So far we're just moving left and right, but up and down is also a thing that can happen. And so what do I need to do if I want to make my ball move not just horizontally but vertically? What does that tell me I need to add into my code? Can somebody give me some suggestions on what additions would need to be made to take vertical motion into account? Yeah, in the back. So I agree with the back half of what you said. I don't think I need another loop though, the first thing that you said. I think our one loop is good to go. But I definitely love what you said about, yeah, we just need more variables, right? We need more variables. In fact, I would say this variable is a little bit misleading. This isn't just the ball velocity, it's the ball x velocity. It's the velocity in the horizontal direction. So we should probably be clear about that and change the name of it to say ball x velocity. And then what I also need to do is make two variables for the ball y position and the ball y velocity. Right? Once we have these two variables, we have to think about, okay, what part of the code is responsible for updating the position of the ball? And it's this part right here. So you can see I have a line here for updating the ball's x position. I also need a similar line to update the ball's y position. So I can go ahead and copy this and swap out the x's for y's. And then hopefully we will have a ball that moves not just in the x direction, but also in the y direction. Let's test it out. Uh-oh, it's not moving in the y direction still. It's moving in the x direction. Here's a little secret. I knew it wasn't going to work. There's a mistake still. Does anybody see what the mistake is? It's actually on the screen right now. Yeah, go ahead. When we draw the ball down here, you can see, 0.5, that's one, what did I call that again? 0.5 is an example of a magic number. I don't like those. Let's get it out of there and replace it with the ball y position. There we go. That's why it wasn't moving in the y position at all. I didn't have the y variable in there. So now that we try it again, hopefully you'll see, oh, cool, yeah. Now we're talking. And, whoop, okay, so it did bounce at the very end there off of the side, but it didn't bounce off the top. And actually, I'll save us a little bit of time and say that it also wouldn't bounce off the bottom. But we can cover that. We know how to cover that. We actually have to do the same thing that we did here, just in the y direction as well as the x direction. So I'm actually just going to copy this and switch all the x's to y's. And then I may actually come up here as well. This starting position at 0, 0 is always going to put us in the lower left corner, right? But we could, there's a few things that we could do to make this more interesting. Well, maybe I'm getting ahead of myself. Let me check my collisions first, and then I'll come back and start playing more with the position and the velocity. I copied the if statement that did the collisions for the x and just switched it so that it will hopefully also work for the y. Let's try it out. Make sure that it's actually going to bounce off the top and the bottom as well. Okay, yep. We'll wait for it to bounce off the bottom corner too, hopefully. Perfect. All right. So now the ball is contained. There's no way it's leaving those bounds. I mean, it's possible we made a mistake somewhere, but I've certainly tried to make sure that this is going to stay within the bounds. Let's play around with these starting values a little bit. I think we can inject some randomness into this, perhaps, by saying, so for example, math.random, I think works really well here. Why is math.random a good fit for the ball X position? Math.random gives me values 0 and 1, which is also the size of my screen, right? So math.random works really well for that. It gives me values between 0 and 1. And so I know that it's guaranteed to be somewhere in the screen, but I don't know exactly where within the screen. Let me randomly generate the Y position as well. The starting Y. These are our starting positions. I should probably label that. And now we should hopefully have oh yeah, that was a random position. Now the bouncing will be a little bit more interesting to watch. It's not just going to bounce back and forth in the same corner anymore. Could we randomize the velocity too? We definitely could. I don't know that I want to just do the same thing though, because consider math.random can give me a value between 0 and 1. If it gives me a value that's very close to 1, what does that mean for my velocity? It's going to jump the whole screen in one frame. That's probably too far, right? It's not going to look realistic. So we need to temper it. We need to scale it, which I know maybe it's too soon to talk about the exam, but the way we scale random numbers, as we saw in the exam, is we multiply them by some value. So if I want to make sure that it remains sufficiently small, I might multiply it by 0.05 or 0.01, something like that. Let's try that for both the X and Y velocity and see what effect that has on us. Okay. And if I start it again, it should be totally different, right? It should be different random stuff. Slow this time, but yeah. I get a different motion, different starting position each time. That's cool. And if you want to be silly and crank the velocity up just to see what happens, that's always a fun thing to do, but it's not going to be the most practical. Well, I mean, that doesn't look all that bad. It's fast. I agree that it's fast, but it doesn't look all that bad, right? It still looks like it's bouncing pretty good, even with that fast velocity. Any questions so far? I'm about to take a step in a different direction. Does anybody have any questions so far about the parts of the animation or how we made that ball start bouncing around the screen? Yes? Is it this line you were? Yeah. Sorry. So this is the X coordinate where I draw the, and that's a good point. Maybe I glossed over this part a little bit too quickly, but standard draw dot point is part of the API. So let's look it up real quick. I probably should have taken a moment to do that. Control F is your friend when looking at these APIs, right? So I'm going to Control F and look for point. And somewhere in here it'll show me where, here it is. Here is the point method. You can see that the first value should be the X coordinate and the second value should be the Y coordinate, and it will draw a point centered at X and Y. Yeah. So I did go through that too fast. I appreciate you having me back up and tie it all back together. Any other questions before I move on to something a little, same example, but something a little different? Yes?
Yeah, we would initialize the positions for X and Y. Before you said random, you said 0. So I'm curious why the ball was in the middle. It started in the middle of the screen as opposed to the bottom one.
So when these were both 0, it was starting in the bottom left corner. But I feel like that might not be exactly what you were asking. The very first time that we had the example up, like before I changed anything, it appeared halfway up because the Y coordinate right here was hard-coded to be 0.5. But I replaced that with a variable that is changing over time, right?
Also for the application, why did you use analysis instead of width?
Is it possible for it to go off the side and the top or the bottom at the same time? think it actually could be, if it lines up perfectly with the corner, it could need to reflect both the X and the Y velocity on the same frame. That is possible. It's rare, right? It's not going to happen often. Maybe not even at all for a given run of the program, but it could happen. So I think making these else ifs, well, and honestly, even if you made this an else if, it would still probably work just fine 99.999% of the time. You may not even notice a difference, right? But I do think it is slightly more technically correct to keep these separate. Whether it goes off of the top or the bottom is not related to whether it goes off the left or the right. Those are two separate directions, right? They're not connected. But I like that your brain is thinking about it that way. Yeah, awesome. All right, I want to make this a game. That was my stated goal at the beginning. And that implies some sort of human component, right? Some sort of way that a person can interact. And the way that I'm going to do that, there's lots of ways to do that. Maybe you can't tell, but I like to play video games. And so a lot of times I use a controller to play video games, but other times I'm using the keyboard and the mouse. And that's more what we're going to be doing in this class. Specifically the keyboard. I'm going to focus on the keyboard for today. I want to have a way to make something that represents me, and I need to have a way of moving myself around the board. We're going to play, my goal is to hopefully play a little bit of a game of dodgeball, right? Send this ball, well, that's an old version, but have this one ball bouncing around the screen, maybe not quite that fast, and then have another circle that represents me, and I just have to try and stay out of its way as long as I possibly can. That's sort of the goal that I'm working towards. So let's talk about that. In order to have something that represents me on the screen, I'm going to need more variables, right? I have variables for the X and Y position of the ball. I also am going to need variables for the X and Y position of myself. So let's go ahead and start those. Player X, and I'll have it start myself just in the very center of the screen. I'm not going to make this part random, although you could make the player's position random if you wanted to. There's nothing stopping you. But I'm just going to have us start in the middle of the screen just to keep things somewhat simple. For the player, let's talk about motion. Let's talk about animation, right? The player's not constantly moving. The player is moving based on when keys are pressed on the keyboard. So if I push up, I want it to go up. If I push down, I want it to go down, etc. So I'm not actually worried about the X velocity and the Y velocity so much. I would say that in this case, having one variable to represent the velocity for the player is actually enough. So I would say something like player speed is equal to 0.01 maybe. I don't know if this number is good or not. We may have to do a little bit of trial and error on that to see if that's too slow, too fast, or whatever. But all I'm trying to do right now is get a second circle on the screen to be me. And then I'll worry about making it move, right? One step at a time. So now that I have these variables, I need to draw it on the screen. So down here's where I draw the other ball that's moving around. Let's draw myself now. Standard draw, dot point, player X, and player Y. And hopefully, even though it's not going to do anything yet, I will see that I now have two circles on the screen. One that does its thing, and one that's eventually going to represent me, even though it doesn't move or do anything yet. There I am. That's me. So no motion yet, but at least I got two circles on the screen. That's all I was going for. So now let's talk about motion. Now let's talk about how we can make that thing move. In order to do that, we need to use the keyboard. How do you use the keyboard? Well, some of you might be thinking, Scanner. Scanner does keyboard input, right? And you are correct. Scanner does keyboard input, but unfortunately for us, Scanner's not going to help us here. And the reason why Scanner isn't going to help us here is because of the time that is involved, right? In order for Scanner to work, I have to type something in and then push the enter key. And anyone who's ever played a video game before knows that you don't have to push the enter key every time you want to move around. You just push the button. So Scanner is not instantaneous feedback, in other words. But fortunately for us, Standard Draw has a way of doing keyboard input. So again, instead of scrolling through this whole document and trying to find it, I'm going to do a Control F here and search for keyboard. right? And maybe keep looking around until, here we go. Keyboard and mouse inputs. That's great. This one in particular, there are a few listed here. Has next key type, next key types. I would encourage you to take a look at those, but the one I'm actually interested in for today is this one, is key pressed. So if I click on this, it says that we have to give it a key code. We have to give it a key code which represents the key that we want to check. So I'm going to use the W, A, S, and D keys for our motion today. You could use the arrow keys if you really wanted to. But let me show you, so you might be wondering, what's the key code? How do I know what the key code is? Well, let's type it in. Key code Java. And again, I'm looking for the one that's sponsored by Oracle. Although this one's probably not a bad result either, but this one is, from Oracle. So if I click on key code, it's going to show me all of the different key codes. These are all the different keys that exist on the keyboard. And we're quite literally looking for the one that represents the letter W. So, there is one. In fact, I passed it, I guess. T-U-V-W, yeah. So there is one that represents the letter W. How do we put that into our code? Well, let's try it out. We need to use the is key pressed from standard draw. So, and I guess another question is, where do I put this code? I'm talking about updating the position of myself. So it's going to go in this middle section where we update the positions of everything. So I'm going to have another if statement down here. If standard draw dot is key pressed. And now here's where I need the key code. It's going to look like key code dot what is it? I might have to do a little bit more Googling to figure out how to get this to work here. Just a second. This is these are the wrong key codes. I'm struggling right now, but you know what? I'm glad that you all get to see me struggling, because I've been programming for a long time, and I've even done this example before. So I know what I'm doing, and yet I'm still struggling getting this keyboard working. And I'm telling you that because all programmers have gaps in their knowledge, right? Don't feel like you have to memorize all this stuff. Don't feel like you have to know everything. It's not possible. It's not possible. It's okay to not know something and admit that you don't know something and have to use a little bit of extra help to help get it to work. So just trying to find the right way to do this. Standard draw key code. Give me an example. Oh yeah, this is what I'm looking for. Something like this. Perfect. Key event. Key event is apparently the missing link that I needed here. So sorry that I had us barking up the wrong tree. Key event dot VK, which stands for virtual keyboard underscore W. This leads us to the W key. And if the W key is pressed, that means I want us to move up. It's probably unhappy because this needs to be imported. So there actually needs to be an import statement up here at the top. You can type that out yourself if you want to, but probably the faster way to do it is to click on this quick fix. And you can see that the very top event is VS Code trying to help me out here and say, hey, do you want me to type this import for you? And if you scroll up here to the top now, you'll see that by clicking those buttons, it typed that line of code in. You can type that line of code in yourself, of course, if you want to, but VS Code is smart enough to recognize how to do that kind of stuff for us. So take advantage, definitely take advantage of stuff like that. Now that I've finally sorted out the keyboard business, we need to actually make it move up. So I know what my position is. Moving up is going to affect my Y coordinate, right? So my player Y is going to go up. I could actually just say plus equals the speed, the player's speed. So as long as this key is held down, I'm going to increment the player y coordinate by the player's speed. Let's test it out. I know we still have to do down and left and right and all that stuff, but let's run it and see if at least moving up works. Oh, hey, nice. Now, uh-oh, it let me go right off the top of the screen. That's not great. We know how to fix that problem, though. I'm not going to do it because I want to make sure I get through the rest of the stuff that I want to talk to you about today, but you could fix that problem, right? If you really wanted to keep the player inside the box, you could fix that problem. Instead of fixing that, though, I'm going to move on to the other directions. So I need directions for down, and this, I think, is a great example of an else if, of when we should do an else if. Although, actually, let's talk about that for a second. If I just did an if statement, that would allow me to potentially hold down two directions at once and move diagonally. Maybe that is something that I want, right? If I use an else if, it would come across the first button that I press and ignore all other buttons. Do you understand the difference? One is not necessarily better or worse, they just have different effects. And it's up to you as the programmer to decide which one you want. So maybe keeping them as separate if statements is better. But regardless, I'm going to do this 3 more times, once for each direction. So the down key is not going to be W, but S. And instead of adding to the player Y direction, I'm going to subtract from the player Y direction. So with that second if statement, I should now be able to move both up and down. But still no left and right. Still can't get there yet. But hopefully by now you can kind of see where we would go. I'll copy this 2 more times. I need to fix these comments too. It'll bug me that they are not accurate. This one will be left and this one will be right. So to move left, we need the A key. To move right, we need the D key. And then instead of affecting the player Y coordinate, left and right is going to affect the player X coordinate. So I'm going to switch those out for player X. All right. And now, hopefully at this point, we can move. Uh-oh. Oh, I see what I did wrong. Hopefully you all see the bug that I made as well. I was pushing right and it was still moving me left because I have both of them set to subtract. I forgot to flip the sign. That's an easy fix though. One more time and hopefully now I can move whichever direction I want. Yeah, there we go. We're now controlling the player. Wow, that ball is really moving. I'm going to leave this here up on the screen while I pause for a moment and ask if anybody has any questions for me before we move on to the next part of today's activity. Any questions I can cover about the keyboard stuff before we switch? Okay. Well, now we need to make things a little bit more interesting. So I said I wanted to play a game of dodgeball, right? So I wanted to actually, have something happen when these two collide with each other. But in order for me to react to a collision, I have to know whether a collision is taking place or not. And this is called collision detection. It is one of the most common things that you're going to find in any video game, right? Two objects running into each other. And the good news is that it's something that you probably already know. It's a good old distance formula. It's a good old distance formula. I'm going to take the distance between these two things. I know the radius of each of these things, right? So if the distance is less than the combined radii, I know they must be overlapping. They must be touching. Let's work on the distance formula. And I don't have the distance formula memorized. It's not that hard, but I'm going to look it up just to make sure I don't get it wrong. Here it is. So we're going to say that, the first one is the moving ball, and the second one is me, the player. And we're going to start constructing this together. Let's make a line of code to check for collisions. Double distance is equal to, the first thing that it tells us to do is a square root. I think we've had you play around with square roots before, but if you haven't done square roots yet, it is part of the math library, which is another example of an API. So if you take a look at what the math library provides for you, it's got a few constants, Euler's number and pi, those are good to have. And then all of these nice math functions, including absolute value, all your trig stuff's in there. So that's nice to have available. But the one that we're really looking for right now is a square root. And if we come down here, we'll eventually find the square root. So we'll say math dot square root. We're taking the square root of the x position minus, so both the x position, the difference in the x position squared and the difference in the y position squared. So player x minus ball x, but we need to square it. In order to square it, we can use yet another math, another thing from the math API, math.pow. Not power, pow. Yeah, there we go. So this is my base, and this is my exponent. Now I need to do the second part. I need to add the difference of the y positions squared. Math.pow. This is getting to be quite a long line of code, huh? Player y minus all y squared. So there's the whole distance formula. If that long line makes you uncomfortable, break it up. Break it up into smaller lines. I almost wanted to do that, to be honest with you. The thought crossed my mind, but I've already got it written out, so I'm gonna leave it for now. If I made a mistake, I might break it up into smaller chunks to help me out. But for now, I think it's okay. And now we just need to check and see what that distance is. We just need to see what that distance is. I know that the radius of each ball is that. There's my radius right there. So if the distance is less than twice that radius, I have two balls, so twice the radius. If the distance is less than twice that, it should be, that indicates that there's a collision. So I would say if distance is less than 0.1, yeah. So if we make it inside of this if statement, we have a collision. What do we want to happen upon a collision? I mean, it's a game. We can make lots of things happen. But for now, what I'm going to make happen, just so that we have some sort of visual cue, right, to know that it worked, I'm just going to reset the player's position back to the very middle of the screen. So if I move around and I get hit by the ball, it's going to put me right back in the middle. I'll say player x is equal to 0.5. Player y is equal to 0.5. Oops. Let's try it out. I think before I try it out, just to give me some chance, my reaction speed isn't nearly as good as it used to be, but this velocity is way too fast. I'm gonna make it slower so that I actually stand a shot of dodging. And then let's try it out. Oh, well, it gave me a very easy spot too. So yeah, as long as I'm out here, nothing to worry about. But if I come up here and I let myself get hit, boop, took me right back to the center. Now, it did look like it wasn't the best collision. Notice the collision, I think maybe, did I do my math wrong? Because you can see that it's kind of working, but it looks like there's a lot of space. Maybe I did my math wrong. I wonder if it should be 0.5 here instead of 0.05 here instead of 0.1. But that's an easy thing to check, right? Tweak the number. Oh my gosh, it's moving fast now. Oh my gosh. Boop. Yeah, oh, okay. I think it's working a little better now. And when I collide, it takes me back to the center. That's how I know. Yeah, looks great. I think it's working. It may look like it's not working when it goes through me in the middle. It is putting me back in the center, but it doesn't look like it because I'm already there. But I think it's actually working. I think it's working pretty good. I got a couple more things I want to show you with this example with the 25 minutes that we have left. But before that, does anybody have any questions about that piece that I just did regarding the collisions? I think I have two more things on my agenda to talk to you about. This next one was actually not in the prep work today, but it's one that is going to be on the homework assignment. So that's a big reason why I like to talk about it in class. And it involves time. It involves time. I've made a little dodgeball game, and it kind of works, but I want some indication of how well I'm doing. Typically with a video game, that would be a score, right? So I think the longer I'm available, the longer I'm able to successfully dodge, the bigger I want my score to be. And the simplest way I can think of, right, is that for each second that I successfully don't get hit, that's going to give me a point. So that's what I want to work on next, is how do I incorporate some element of time into the works and include a score as well. So let's go up to the top. Since I'm talking about score, I need a variable. So int score will start out at 0. I don't get anything for free. Have to earn it. But now let's talk about time. The way that we get time on the computer is by using something called system dot, and wow, VS Code is very smart. It knows exactly what I want. Current time millis, which sounds it's exactly what it sounds like. It is telling me what the time is right now in milliseconds. In milliseconds. And the time, by time I don't mean 1:57 p.m. Actually, the way this, again, might sound a little silly, but it's true. The way time is computed on most computers is the amount of time that has elapsed since January 1st of 1970. So is this quite literally going to tell me how many milliseconds have elapsed since that particular date? That doesn't really matter though. What I care about is, has it been 1 second or not? So what I'm going to do is I'm going to create a variable to track the time. So, I'm going to call, and also I should mention that this is kind of an int, but you'll notice that I can't use int here. So if I say int, current time, it gets mad at me because integers only go up to 2,800,000,000. I don't know the exact number. Integers only go up to 2 million something. They can't, 2 billion. I'm sorry, not million. 2 billion something. If I try to represent a trillion, I run out of space. Integers aren't big enough to handle numbers that large. So for numbers larger than 2 billion that are ints, there's actually another type called a long. A long is exactly the same as an int. It just allows us to have bigger numbers. That's all. That's the only difference. So honestly, when I see longs, my brain thinks int, because they are so very similar to each other. Okay, so what this is going to do is record the time when my program first starts. And what I want to know is when it's 1 second later than that. I know there are 1,000 milliseconds in a second, correct? So inside of my while loop, I'm going to ask what time it is again. I asked what time it is up here at the very beginning. I'm going to ask what time it is again inside of my loop. I'll call it now. If the difference between now and the very first time is greater than 1,000, I know that 1 second has passed. Does everybody understand why I'm able to make that claim? Do I need to go back and explain why that is a reasonable thing for me to say? Is there anything I can do to help clarify that? if the distance between here and here, so think about it. This amount of code takes some amount of time to run. I don't know how long, but who knows? It could be 5 frames before a second has passed. It could be 30 frames before a second has passed. It doesn't really matter to me. I'm gonna check every single time how much time has passed. Has it been a second? 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 Eventually the answer will be yes, it has been 1 second. And at that point in time, I want to increase my score by 1. I've lived 1 more second, I get 1 point. I get 1 point. But now I have to update my time because I now want to know when it's 1 second from now, right? Not 1 second from the past, but 1 second from right. So in other words, I'm starting my second all over again. Does that make sense? Right? I have to start my second all over again. So my current time that I'm comparing against is actually going to be equal to right now. And I don't actually like the name of this variable, to be honest with you. This should be like, you know, past time, really, not current time. It's a poor variable choice, poor variable name choice on my part to call it that. But functionally, it should work. Functionally, it should work. Now, I've written a lot of code. Unfortunately, there's not much I can do to test it yet because I can't see the score. I can't see what my score is. Presumably, I'm earning points right now because I'm successfully dodging the ball, but I can't see it because it's not shown to me on the screen anywhere. Maybe I could, you know, print it out, and in fact, I could. I could stick a print statement in here with my score, and if I run this, you'll see, oh, it says a bunch of zeros down at the, oh, and then it counts up. You can see it is working, but I don't want it down here. I'm trying to make a game, right? Well, can I put it here in the screen? Can I put it here on the screen? The answer is yes. Absolutely, I can put it on the screen. That's an example of text. So if we go back to standard draw and we do a search for text. Oh, here we go. Text. And if I look at this first one, it says writes the given text string centered at x, y. So here's my x, here's my y, here's the text that I want. So, okay, let's add that to our code. Here's where I'm drawing everything. So I'll come down here and I'll say standard draw.text. I want it to go, where do I want it to go? I want it to go like right in the middle, close to the bottom of the screen. So what x coordinate am I looking at right here? That's about 0.5, right? And for the y coordinate, 0.1, maybe somewhere in that ballpark would work. So 0.5, 0.1, and then what do I want it to say? I want it to say score, and then I'll concatenate the actual score variable on the end. And now hopefully instead of just showing up down here at the bottom, we'll see that it shows up on the actual screen. There it goes, and it counts up. Every second I get 1 more point. Oh, and now when I get a collision, what should happen? It should probably reset my score back to 0, right? I mean, it doesn't have to, but you can see that it doesn't. But what if I wanted to do that? Well, let's go find where it does the collisions, and oh, here we go. Here's where it says check for collisions. I'll also reset my score. Score equals 0. Now when I rack up some points, and then, oh, it took me back. You can see that it does reset me back to 0 after I get hit. I think there's a lot of other cool things that you could do with this, like, for example, you could remember the high score. That's something that I see a lot on games like this. Put another label on there that says high score, and then every time you get a score that's bigger than the high score, you write that on the screen too. I think that would be a great way to update this code. But I have one more addition that I would like to make to this code before we call it a day. Before I do that though, any questions, anything you'd like for me to go back? I know I did some of these things maybe a little bit fast, so if somebody wants me to go back and re-explain a part, I'd be happy to do that. Not seeing any hands though. So I'm gonna do one more thing to make this work. Right now, I'm just dodging 1 ball, right? I'm just dodging one ball. And you know, the ball's moving pretty fast, but it is pretty easy. I can make this a lot more challenging by having more than one ball moving around the screen that I want to dodge, right? What would I do if I wanted to do that? If I wanted to have not just one ball, but maybe 3 or 10? What would I do? What would I need to incorporate into my code to help me keep track of not just one, but multiple balls? Any ideas? It's everybody's favorite thing that was on the exam last week. Yeah. I think we will be using loops, but the word that I'm thinking of rhymes with hooray. Right? We need an array. We need an array. We need an array. In fact, I would argue that we don't just need one array. Think about it. For each ball that I have, every single one of them is going to have an X position. Every single one of them is going to have a Y position. Every single one of them is going to have a velocity in the X and Y direction. I think I need probably 4 arrays. 4? So let's do it. We've got enough time, I think, to make this happen. And it's surprisingly not as tricky as you may think. Instead of having it like a single value, I'm going to add brackets on the end of each of these. That now makes them arrays. But that also means that I can't do this stuff on the right-hand side anymore, right? I have to actually create an array here. So, okay, let's just create an empty array. I'll say new double. And I have to decide what number goes inside of the box. Well, what number goes inside of the box is going to tell me how many of the balls that I'm keeping track of. So actually, it might be wise to even make another variable, int number of balls. And we'll start with, what, 3? Just to keep it not too crazy. And then inside of here, inside of the brackets, we can use that variable. That's a nice way of doing it, because if I decide later that I'd rather have a different number of balls, I can just change the value of this variable and all of the arrays automatically will update accordingly, right? Magic numbers are bad. If I put the number 3 in there and I won't decide later I want to change it, I have to go change all of it. So using a variable is nicer. But yeah, we'll create all of these arrays. They all get created in exactly the same way. But what's in these arrays after I create them? 0. That's not what we want. So I need to write a loop that somebody suggested just a moment ago to go through this array and set the starting values for all of these. So in other words, all that math.random stuff that I had before is still good. I just need to put it inside of a loop now, so that I'm doing it once for each entry in my array instead of once for the ball. So I'll say, you know, this is the classic array traversal. This is the same array traversal loop that Professor Nuri wrote. I don't even know how many times, or was it me? I don't remember who taught that class. Maybe it was me. It's been a while. It's been a week or two since we did that. I++, oh, not ball x, ball x dot length, or actually, the better thing would be number of balls, right? Okay? So for setting the initial x position, I have to say ball x at I is equal to math.random. That will generate, this whole loop is going to be for generating starting values. So now let's generate the starting values for the other ones as well, including the y direction. And then we're also going to do it for the x velocity. For the velocity, it definitely needs to be scaled down a bit so it's not too fast. And we'll switch this to the y velocity. So I turned all of these into arrays, but now I had to write a loop to go through and set the initial starting values. I don't just have one variable, I have a collection of values in an array. And then actually down here, if I scroll down, you'll see that, oh shoot, all of this is underlined in red now because this isn't just one value, it is now an array of values. So I have to use square brackets, but that's actually not that hard of a thing to fix. It's actually not that hard of a thing to fix. I need another loop here, just like the one that it's the exact same loop. It's the exact same loop that I had up above. So I need another loop here. I is less than number of balls, I plus plus. And now, oh, where's the end of the loop? The end of the loop is gonna be, I actually have a little bit of an issue, do I? Well, let's take it one thing at a time. The end of the loop is gonna be over here because the player, this has to do with the keyboard. And notice that there's only one player. So the stuff for the player is not in an array. There's only one player entity, so it doesn't need to be an array. Only the other stuff. But now this all becomes very simple. Instead of ball X, it becomes ball X at I. And I'm literally just adding the brackets on to every single one of these, right? To indicate that it is in fact an array and not just a single variable. So once I get through this in just a second, we'll just a few left here. So all of those have to be using array access. My indentation is a little bit messed up. I'm going to try and fix that real quick. There we go. That looks a little bit better. So now, instead of checking to see if one ball has gone off the edge, I'm using a loop to go through the array and checking if every single ball in my array has gone off the edge of the screen. Does that make sense? I hope. I hope. And there's one more thing. There's one more error you can see down. Well, actually, a couple more errors you can see down here. For collisions, I need to check to see if all of the balls are colliding, not just one of them. So actually, this check for collisions, I would argue, needs to be moved up to that loop that I just made. You could write another loop down here, but why? We've already got a loop up there that's doing what I need it to do. So I'm actually gonna move this code, take it out of this section, and put it up here in the loop. And just like we did before, instead of just ball X, this is an array now, so I have to reference it using the square brackets. And same thing here for ball Y. That's an array, so I have to reference it with square brackets. And there's one more error that we have to fix before we can test this out and see how it works, which is this. This was fine when I was just trying to draw one ball flying around the screen, but now I'm trying to draw a whole bunch of them. So again, these are arrays. I actually am gonna am gonna write another loop here. Could I take this line and move it up to that other loop? Yes, but I like to keep my code organized. So step 1 is clear the screen. Step 2 is update the positions. That's what all this stuff is updating the positions. Step 3 is draw everything. So I like to keep the draw everything separate from the updating positions. So I am going to write a second loop here, but if you want to experiment with copying that line up top, it may work. This may be a little redundant perhaps. And I'll just add the brackets here with I. And hopefully, all the red is gone now. It's still possible that I made a mistake. But hopefully, if everything went well, we'll see that now I have 3 balls flying around the screen. And if I collide with any one of them, it's going to send me back to the middle and reset my score. It looks like it's working pretty well. The flickering is a little bit annoying. I think maybe the frame rate could help with some of that problem. But there's actually a couple other things that real quick I can do. You know, the player is the same color. Everything's red. It would be nice if I made myself a different color. We can do that. Standard Draw has a way to change the pen color called Set Pen Color. And I would like for this to be black, maybe, instead. And now it'll be a little easier for me to see. Oh, whoops. I need to set it to red for the first loop and set it to black for the player. So I added 2 lines here. That'll make sure that these all get drawn in red, and this will make sure that the player gets drawn in black. Let's try it. Oh yeah, there we go. Now it's a little easier to see what's going on. Notice there are still a few things that I would like to fix. Namely, they don't collide off of each other. So if the red balls bounce into each other, they just go right through each other. That's fixable. You could fix it. I don't have time to do it now, but you definitely could fix it. The border thing is a problem, right? Something else that I can and have done with this game before, but I don't have time to do right now. Every 10 seconds, what if I wanted to add another ball? Very doable, and I would encourage you to think about what changes you would need to make in the code. But before you leave, one final, I promise this is the last thing I'm going to show you. Let's crank it up a notch. If I did this properly, I should hopefully be able to change this to be like 20, right? Oh yeah, whoa, ah! My computer's struggling a little bit. I'm not going to deny that, but it's doing what I asked. And there's no way I'm going to do very well at this game. But right, you can see that the sky's the limit. I can put 100 of them on here, and it'll, oh my gosh. My computer can't keep up. That's my computer saying, please, no more, please. But yeah, have some fun with it. There's lots of different things you can do with this. I'm out of time for now, though. Have a good rest of your day, and I'll see you all in the labs on Wednesday.